Cayenne. Okay, and this is where we go to the design for tension members. Okay, so we have ilang steps yan, 1, 2, 3, and 4. Okay, so number 1 is we first calculate the minimum gross area for yielding. Okay, so we have equations derived from the code provisions for the design of tension members. Okay, the minimum gross area would be equal to your ultimate tensile strength PU, or this is your factored load. PU, di ba guys, if you remember, meron pong pumapasok. Rochelle. Di ba? For LRFD, narinig niyo ako ha? Our P sub U should be less than or equal to our PN. Okay? Wherein, this is from our factored load. And this is the capacity of the material. We call this our factored resistance. Okay? And phi, of course, is our factored resistance, factored load. Phi is our reduction factor, wherein we cannot use the entirety of P sub n, but we reduce it through a factor less than 1. Okay? And for ASD, our allowable tensile strength is equal to our nominal tensile strength divided by a factor of safety omega. Okay? Ayun. And then, of course, we have the computations for the PN. For gross area yielding, or gross section yielding, what is the formula? Our PN is equal to your material yield stress Fy multiplied by the gross section area. And for net section rupture, nya pag marmaritesan talaga ito niya. Net section rupture, our PN is equal to your ultimate tensile strength multiplied by the effective net area, wherein the effective net area is computed using our shear log factor capital letter U multiplied by the net area of the section, wherein the net area is equal to the gross area minus the area of the holes, okay, plus the effect of its staggers if there exists. Okay? So now, for the computation of the minimum gross sectional area or gross area, galing lang yan dito, guys. Okay. Since for gross section area, it is, for LRFD, it's PU less than or equal to VPN. No? So that PU, if we divide that by the factor of safety, that's less than or equal to, what's PN? FYAG. So that our gross sectional area should be greater than or equal to, tama ba? PU all over P times Fy. Wherein PU is our factored load. Okay, depende sa load na ibibigay sa atin. Ang init. So yung AG dito, that becomes our minimum AG. Okay, that becomes, we equate it to P all over Pfy. Okay, and for ASD, ganun lang din. Since for ASD, it is PN all over omega. That's PA multiplied by omega, that's factor of safety, is equal to PN. This should be less than or equal to FYAG. Tama ba? PN is FYAG. So that the minimum gross area for ASD is equal to PA omega divided by FY. Okay? Nilagyan lang yan ng minimum. Minimum. Okay? So, ito lang din yan. This part. Uy, ayun yung kumikot. Okay. And then, for rupture, net area rupture, we calculate the minimum effective area in rupture. Okay, so equations are also derived. That would be our minimum effective net area is equal to PU all over P times FU, since our formula for the nominal tensile strength in net area rupture would be this is equal to FUAE. Okay, so LRFD and ASD, this is for ASD, no? That's PA times omega, factor of safety, divided by FU. And remember that there are different safety factors and reduction factors when we are considering yielding section or can be computed as your PU divided by our reduction factor phi multiplied by FU times our shear log factor U in LRFD. Okay? And of course, for the computation of the gross area, kasi ito naman yung gross area ang titingnan natin doon sa section properties class, doon sa ating section database. So that would be equal to, di ba, ang pag-compute natin ng net area, that is equal to the gross area minus yung area ng holes. Okay? So that the gross area then would be equal to your net area plus the area of holes. If we are computing for the minimum gross sectional area, then that would be minimum AG is equal to minimum AN plus the estimated hole area. Yun yung area of holes dito. Okay? Huwag kayong malilito dyan. Okay. Now, all in all, plus, you can use this formula. The minimum gross area now would be equal to PU all over phi FU times U factor. Ano yun? Wait lang. Okay, plus the estimated whole area ito class. Alright, now in ASD, the minimum gross area, okay, for net section rupture ito class ha, it would be equal to our service load. Service load ang tawag class sa PA. Ba't di ko binigay yon? Okay, PA is our service load. Doon sa ASD. Ito, this is PA. Pinagsasabi ng mga kasi. Wait. Pangbaliw. Ayan. So, once the trial section has been selected, properties of section are known and must be checked. if it satisfies the design tensile strength or allowable tensile strength or allowable design tensile strength, that should be greater than the actual factored load and service loads. Also, check for slenderness ratio that should not exceed its limit of 300. Our slenderness ratio class, it is not given here or that is equal to L all over R should be less than or equal to 300. Hindi dapat siya lumampas dito. So that the computation for our R, guys, yung R dito is the ano ba, least ba or yung mas malaki na radius of gyration. So if you remember, we have hindi pala. Kasi lockdown na nag-integral tayo. Okay, radius of gyration is also part of integral calculus and it is also a section property. Okay, if you go to our section database, we have R sub x and R sub y. Ang pinipili natin is ano yung design? Wait lang, hindi ako kabisado para hindi ako malito. Design for tension members. Is it the minimum or okay, although guys, sinabi naman sa libro, no, that slenderness has no structural significance kapag nagre-resan tayo ng tension members, but we still have to meet what the code requires, that slenderness ratio L all over R should not exceed 300. Where R is the minimum radius of gyration of the cross section. Okay. So whatever yung ang napipilitin natin for this condition, okay, would be the list of R sub x and R sub y. We can, eto kasi nakikita natin ito sa ating section database. Okay. So our R minimum, to compute for our minimum radius of gyration, it should be tama, ito, it's like cross multiplying, no? It should be greater than or equal to L all over 300. Okay? L would be the length of the member, no? Of our tension member. Okay, and divide that by 300 to compute the minimum radius of gyration. Alright? Naririnig nyo ba ako? Naka-open naman yung mic ko.
Yes, sir.
Alright. So you have an example here. Okay? So, naka-English pa rin ito. Kinonvert ko lang sa ano. So we have here in the figure, no? So we have a plate. We have ilang connection yan. We have 8 bolts. Okay? 3/4 inch diameter. Okay, what is 3/4 inch again in millimeter conversion? That is 19 pa rin ba? Ito rin 19. 3/4 times 25.4. That's 19 mm plus 19 mm volts. Okay, so this is the gasset plate kung saan nakakonect yung ating tension member. Alright, and this is the angle. Ito yung kanyang flange. Or this is the other leg. Okay, itong part na ito. Ayan. So, the other leg is connected, no? So, ano to select an unequal leg equal tension. So, unequal, no? So, hindi natin ito sa mga equal legs. Yung mga 6x6, 4x4, 8x8, mga ganun, 5x5. Hindi tayo mag-choose sa mga ganun. Okay? And also, it is 4.5 meters long. Okay, can you imagine that member? 4.5 meters. And it is to resist a service dead load. So, lagay natin yung mga loads. A service dead load of 155 kilonewton. That's dead load. And a service live load of 310. That's not Kipp's class, that's kilonewton. Kasi naka-Kipp's yung given sa libro. That's 310 kilonewton. Okay, we are to use A36 steel. So for A36, Fy is equal to 248 megapascal, and Fu, our ultimate tensile strength, is equal to 400 megapascal. Okay, so we are to use 8. So solution, select an unequal angle. I have to open my section database. So single angle lang yan ha, class. Asan yung office? Birds. 19, 22, 22, 23, 24, 25 lang. Ayan. Okay. Dito mag-start yung SI. Alright. So this is the section database. I hope everybody has downloaded this worksheet. No, nasa ano natin, nasa SIAS. So select an unequal leg angle tension member, 4.5 meters long. I will write the length. Length is equal to 4.5 meters, or that's 4,500 mm. Yun. So first we consider LRFT to design the member. Okay, and to find the suitable member to resist that load, no? Service dead load of 155. So guys, for LRFD, the most common that we use, no? If we are is load combination 1 and load combination 2. What is our load combination 1? If you remember your module 1, that is equal to 1.4 of dead load. Okay, what is 1.4 dead load? If dead load is 155 kilonewton, is equal to 217 and Bernadette. Okay, that's PU. Okay, another one, load combination 2 is 1.2. This is the most common, no? Na lagi niyong ginagamit sa RC design. 1.6 dead load plus, 1.2 dead load plus 1.6 of live load. And that is equal to, what's the value, JSM? Tingnan ko ako nakikinig ka. For load combination 2, what is the factored load? Mr. San Agustin. Andiyan pa ba siya o nag-leave na? Wala? O, anyone? What's the factored load?
$682, sir.
682. Ano yung ballpen ko? Okay, that's right. Miss ko kasi now. 682 kilonewton. So, yan yung mas mataas. Then, yan yung gagamitin natin. Sir, why don't we consider the other load combinations? At for dead load and live load class, ito lang yung consider yung dalawa. No? Kapag dead load at live load lang yung binigay ng loadings. Okay? You only use case 1 and case 2. Case 2, ang case 2 ay kapag lang sobrang, case 1 pala, kapag sobrang laki ng dead load natin, it is much greater than live load. Okay? But, ewan ko, parang wala pa naman ako na-encounter na ganun. So, our PU is 682 kilonewton. Now, we now compute for the minimum gross sectional area. So, minimum AG is equal to, ang sabi? Diba, kung ayaw nyo i-memorize yung formula class, it is just, we'll just use the, PU. You can equate it to PN. Wherein PN is equal to, okay, kasi pati PN ko. Sa bali, kung susukatan na. Phi, first we consider sectional yielding. That is our minimum AG. Agad ang PU. Mati talaga. Balik-balik ko sa suratan. The PU is less than your because FY is in megapascal, that's Newton per millimeter, right? So 600 into 1,000, that's the Newton now. That's the reduction factor for section yielding. Diba? 0.9 or 0.7. Rubber lang or for rubber times FY. FY is gross area. Okay. Considering cross section yielding. Like 3,056, right? Nearest good number. 3,056 square millimeter. All right. And then or radius of iteration muna. Alright, iba na kailangan yung consider observing stability check or check for the radius of iteration. My minimum R is greater than or equal to L over 300. Okay, we have to express it in millimeters. That's L is the length, no, yung live load. Okay, this is 4,500 mm divided by 300. Okay, and then this is the minimum radius of gyration. 4,500 divided by 300 is 15. Okay, now we go to the section database, and then we have to find for sections with the minimum is constant. So this is the minimum gross area, no? We have to look for area that is greater than this. Okay? Pero dapat yung pinakamalapit. Okay? And also for this, the minimum radius of gyration. Yung list ng pipiliin natin, diba? Because that will give the largest slenderness ratio, not the smallest. The sign of tension member. So let's go to 3,056 and 15. Okay, ang area class is along column CJ or in our worksheet. Okay, and we have to look for unequal angles. So ang area dito sa L10 ay, if we start with L10, it is already 9,360. Eh ano lang yung required? The minimum is 3,056. Of course, you will not choose a section that is times 2 of that area, no? Dapat yung pinakamalapit sa 3,000. Lang ngayon, 3,056. Save ko na nga lang sa calcio ko. That's the minimum area. And the minimum radius of gyration is 15. Okay. So, unequal angle. L8 by 8, hindi pwede kasi equal legs yan for an angle. 8 by 6. So, 8,450, 7,420, 6,450, 5,430, 4,910, 4,390, 3,860. Okay, this is for the L8 by 6. 3,864. Let me highlight this. Alright. L8 by 6 by 716. No? 716 is the thickness of the angle in inches. So the gross area is 3,860. That's the nearest L8 by 6, no, to our minimum gross area, which is 3,056. Pero ano pa rin yan, guys, no? Malaki pa rin. And its minimum radius of gyration. Okay, ang radius of gyration class ay mahahanap natin dito. If we move this to dito. This is r sub x. Okay? So it is 65 and r sub y is beside sy. Okay, and it is 45.7. So pasado pa rin. Okay, but sobrang laki pa rin. 65. It is 45.7. Okay, the minimum required is 15. Answer lang ba dito, sir? Ngayon. Mamaya ako sasagutin. Quiz solution. Okay. May quiz kayo next week. Very, very long quiz. Joke lang. May take home pala. Alright. So we have to look for other, masyado pang mataas itong 3,860 class na cross-sectional area. L8 by 4. The nearest is eto. L8 by 4 by 716. Its gross area is 3,300. That's near 3,056, but that is still, that exceeds 200 plus square millimeters pa rin. And the minimum radius of gyration, or its radius of gyration is r sub x and r sub y. That's 31, no, 27.7. Okay, so pasado pa rin. What about L7 by 4? So ano lang plus, mamimili lang tayo ng pinakamalapit sa gross area. The recommended here is L6 by 4. 7 by 4 is, the list is 3,390. Okay, mas okay pa nga yung ano dito. Yung L8 by 4 kasi mas maliit yung 3,300 kaysa 3,390. What about L6 by 4? Okay, we cannot choose L6 by 6 kasi equal legs yan, class. Ang nire-require ng problem is we have to choose unequal leg angles. So L6 by 4, dito siya. The minimum is 3,056. Alright. Ito pinakamalapit. 3,060. Right? What's the minimum? 3,056. Okay, and we have to check for the gross area. Put yun. Gross area nga. Radius of gyration. Minimum. R sub x. By 48.5, R sub y is 29.0. Okay. So this y is our nearest trial section. L6 by 4. Trial section lang natin to, class. No? Pipili pa tayo. Ito pala dapat. Yun. I-check pa natin. L6 by 4 by 1/2 trial section. So the gross area is equal to ilan yan? 3,060 square of millimeter. And R minimum, that's R sub y, is equal to 29 ba yan? 20 R sub y, 29.0. Okay. Do not choose the R sub C, class. Ginagamit lang yan sa plastic design. Just choose the minimum of R sub x and R sub y. Hello, nandiyan pa ba kayo? And then, what else do we need? 6 by 4. Okay. Let's check for the nga, dapat chinik na natin for effective or next section rupture. Pero pwede naman. So this is our trial section. Let me... Ayan muna. Okay, our minimum effective net area, which is given here to be minimum AG for net section rupture naman ito. Pwede, check natin for net section rupture. Net section rupture, that is the minimum AG is equal to PA. No, it's not PA. PU over VFU because we are considering LRFD. VFU times U. VFU times U. Okay. 1 less X bar over L. No, we cannot consider in checking for the yung gross area for uh, net section rupture, we estimate or we assume the least value for the shear log factor U. Now, yes, ang pinaka maliit kasi na value, possible value ng is 0.75. So, to use our trial section, ilagay muna natin siya na yung pinakamaliit, 0.75. So then that would be equal to 682,000. Oo nga, dapat consider nito. All over V, that's 0.75 for net section rupture, times FU, that's 400. MPA multiplied by the least reduction factor, that's 0.75. Para lang makuha natin yung minimum gross area for net section rupture. 682 divided by 0.75 by 400 by 0.75. And we have 3,031 or 3,032. Okay, square millimeter. Okay. So, yun. Kasi pasok pa rin yung ating trial section class which is 3,060. Now, let's investigate. This so, alright. We have to check our trial section for net section rupture kasi syempre we have to consider the connection of I. Ikaw kung talaga yung actual na value ng ating U. And we consider I isa lang pala. If we pass, then that's minus balls. Okay. So, investigate the trial section and is equal to kasi definitely papasa na yung ating section for the cross section yielding 0.4 net section rupture estimated minimum MAD. We have to check. Okay, so A is equal to the gross area minus the area of the opponents. Alright, so for LCC by 4 by 1 plus we have to also get the properties. But we already have the gross area, the thickness for LCC by 4. Ano yung thickness? Thickness is equal to 12 because what's that? Thickness is equal to 12.7 mm. Okay, so dalaga 12.7 yung thickness nito. Okay, so net is equal to gross area, that's 3,060 minus the If you pass a static plane, dalawa yan. Minus 2 times, what is our whole diameter? That is 990. So 990 plus 4. Okay, we get the effective whole dimension. Multiply by the thickness of our angle, 12.7. 12.7 mm. That's our net area for the 3060 minus y is of 247.8 square millimeter. Okay. And then, what? Parang may mali dito. FU times U. The estimated whole area, hindi ko pala yun naitagdag. Ano ba yan? Okay. So, ito may problema dito. We have to add the area of the holes. The area of the holes. Then that is equal to, tanggalin ko to, plus, dalawa, na whole dimension, 23 by 12.7. And that's equal to, the minimum gross area is 682,000 over 0.75 squared by 400 plus twice of 23 by 12.7. It's around 3,615. 3,616 na lang. Square millimeter. Okay? Kasi, mali na to. Because hindi napapasa yung ating section. If we are to compute for the actual value of our shear lag factor U, okay? Anong i-consider natin? We have an angle, okay? That is connected on a 4 bolts in a single line. Okay, so what case is that? We have to look for what the NSCP says for the computation of shear lag factor. Saan yun? One is X bar over L, case 2, and what else? Is it with 4 or more fasteners per line? Okay, that's 0.8. U is 0.8. Single and double angles with 4 or more fasteners per line, 0.8. Or 1 less X bar over L. Okay, but we are not given, hindi given sa problem natin, no, yung L na ito, yung distance from end to end of our connection. So we cannot consider case 2. Since 2 lang yung given. So disregard natin yan. We take U to be 0.8. And if U is 0.8, then our effective net area, hindi na pala. Is equal to UAN, that's 0.8 of 2475. Kasi ang liit na guys ng ating net area. Hindi na pwede ito. That's 1,981 square millimeter. That's the effective net area. Ito kasi yung pag-compute natin ng minimum AG. Iba yung source ko nito. Should be na minimum AN. Minimum AE. Dito. Ito pala dapat ginamit natin. This formula. P over VFU. Gets ko na. .75. Okay. Ganito. We will not consider minimum AG when we are referring to net section rupture. Okay, sorry guys. Mali na naman to. Dapat AE pa rin yung kinocompute natin. The minimum AE, okay, please disregard this. Tinopya ko lang kasi to eh. Eto. We disregard this. We will just use this. Yung pinakataas. Tatanggalin ko yan sa ano. That's PU all over VFU lang. Okay. Yung pinakataas lang. So that to compute for our minimum effective net area, that's equal to 682,000. Kasi hindi natin makapag-compare eh. Paano natin malalaman kung tama or mali? That's Newton divided by 0.75 by FU, which is 400 megapascal. And that is equal to 682,000 divided by 0.75 of 400. 2,274 square millimeter. Okay? So, since our computed AE is less than that, no? Our section, our trial section L6 by 4 by 1/2 is not suitable. Okay? It is less than our minimum AE. Okay, so it will fail in net section rupture if that's the case. So, lalagyan natin dito. Not suitable. Okay, we again have to look for another trial section. Ganun lang yun guys. Hahanap ulit ng another trial section. Okay. So, yun. What about this? L6 by 4 by 916. The net area is 3,430 na agad guys. So, okay. If we compare it to those nakita natin kanina na ito 3,390, ito 8 by 4, 3,300. No? So, kaya sabihin natin yung 6 by 4 by 916, which is 3,430. Let's just check first for this. No? Mas maliit. 3,300. L8 by 4 by 716. Trial. Okay. With gross area equal to ilan yan? 3,300. Makikinig kayo ha. 3,300 square millimeters thickness of the angle is, what's the thickness? That's 716 times 25 all over 4. 11.1. 11.1 mm. And ano pa? The minimum radius of gyration is the minimum of Rx and Ry. Rx is 65.8 and Ry is 27.7. We choose 27.7 para pumasa siya. Since this is greater than the minimum 15, papasa na siya for the slenderness ratio and also for gross area yielding, because the minimum for gross area yielding is 30.56. Sa next section rupture, hindi lang natin alam kung papasa siya. No? So, let's again check. Definitely, papasa na siya for cross section yielding and slenderness check, or that serviceability check. Let's check for net section rupture again. AN will be equal to your gross area minus the area of the holes. Classmate, answer lang ba dito? Salamat sa sasagot. Sandali nga lang. Sagutin ko lang yung estudyante ko, class. Okay, huwag niyo munang babasahin. Anong sinabi ni JSM? Hindi ko nabasa. Hindi niya alam ang sagot. Classmate, answer lang dito. Guys, that activity JSM, anong sinabi mo? Right, this is equal to 3,300 minus, okay, dalawang buwan. Okay, guys. Ano yan?
Ano yun?
Guys, ano yung sinabi mo sa GC na pinag-delete mo?
Sabi ko sa GC.
Okay. The thickness now of our trial section L8 by 4 is 11.1 mm. Okay. 3,300 minus twice of 23 by 11.1. Okay, that's 2,789.4. Alright. And then, our effective net area, since our reduction factor, here that factor U is 0.8, our effective net area is 0.8 of our AN. That's 2,784.89.4. Sorry. And that is equal to 2232. So 2,231.52 mm. So, wait lang, class. Yep. Please just answer your problem set. See you next week. Okay. All right. So our minimum effective net area, okay, is 2,274. So our computed value for our trial section is 2,231.52. Okay. What do you think, guys? Pasado ba yung ating section? Pasado ba o hindi? If our computed effective net area is 2,231 and the minimum should be 2,274. Guys, please answer me. Hindi pa rin, di ba? Because it is still less than our minimum effective net area. Dapat lampasan niya yung minimum effective net area, class. Oh, so anong gagawin natin ngayon, sir? Hindi mag-trial section ulit tayo. Okay. It's not suitable. Not good. So, sabi nga dito. Okay. Not good NG. Okay. Kapag daw umokay siya, di okay. Alright. So, anong next section na i-consider natin? So, let's not suitable, but not good NG. Let's say, what's the next section? Na pwede natin consider. What about this? 7 by 4 by 1 1/2. 7 by 4 by 1/2 has an area of, parang lumampas na ako sa ano. The area is 3,390. Let's check 7 by 4 by 1/2. With gross area equal to 3,300. Dapat mas mataas siya doon. 3,390 ito. Siguro papasa na siya. 3,390. Okay, and then its thickness would be 1/2. 12.7 mm. And its minimum values of G ratio is so kapag kayo ang nagsasolve class, pwedeng isulat nyo na yung mga possible sections na i-consider nyo para minsan kayo mag-check. Okay, and what you think would be the best suitable, okay, will govern your design. Saan na yun? Lumampas na ba ako? R sub y is 28.2. So, pasado pa rin siya. Okay, i-check na lang natin siya for net section rupture. Again, we have to compute for our net area. That's equal to gross area, 3,390, minus twice the whole. Dalawang butas lang. Dalawang butas. And multiplied by the thickness, 12.7. And that is equal to 3,390 minus twice of 23 by 12.7. Okay, and we have 2,805.8. Okay, our AE is equal to UAN, which is 0.8 of 2,805. Ano po na to? Times 0.8, 2,244. 0.64. So, pasado ba? It is still less than our minimum effective net area. Okay, so it is still not good. Okay. Kasi ang sagot sa libro, guys, is 8 by 4 by 1/2. This is 7 by 4 by 1/2 eh. So, pag 8 by 4 by 1/2 kasi, laki na ng area niya. Trial section. Let's now check for 8 by 4 by 1/2. Sorry. So ito yung 7/4. Okay, 90 square millimeter nga lang yung yung naidagdag. Okay, let's now check for L 8/4 by 1/2. It has an area of 3,740. Huwag na dyan, dito na lang. Okay, tanggalin ko na to kasi hindi din lang naman siya pumasa. Okay. So, kapag kayo nagde-design, okay, hindi naman kailangan na isulat nyo lahat ng inyong trial section. Okay, pwedeng maglagay lang kayo ng isang, nag-fail kayo na ma-meet yung requirements, then pwedeng isulat. Although magta-trial kayo sa draft nyo, okay, sa inyong papel, pag nag-submit kayo, okay lang na hindi nyo ilagay lahat ng trial section nyo. Pampahaba lang yun ng susunod. Ang hahanapin ko lang naman kung ano yung pumasa na section. Right, L8/4 by 1/2 ang i-consider natin. Okay, area thickness is 12.7 and radius of gyration. Area is 3,740 square millimeter. And minimum radius of gyration is, pasado na yan. Okay, although we still have to write it. The minimum radius of gyration is 27.4. That's greater than 15, so papasa na siya for slenderness. AN is 3,740 minus twice of the area of the holes. Nautot pa ako. Times 12.7. That's equal to 3,740 minus twice of 23 by 12.7. Okay, 3,155.8 square millimeter. Effective net area, that's UAN. 0.8 of nagpupupan na, nagpagarinteran. Ganda ng neighborhood na to. 0.8 of 3,155.8. Okay, please compute. Wag na ako na lang. That's equal to 2,524.64 square millimeter. So it is now greater than our minimum effective net area. So papasa na siya. Okay, so okay. So finally, our answer is adapt. L 8/4 by 1/2. Okay, kasi pumasa na siya for the three conditions. That is for cross section yielding, net section rupture, and slenderness. Alright. So what else? Mga ibang design natin dito, rods, mga ganyan, mga bolts. Yes, sa last tie rod. Last part na yun. Okay, design of purlins. What else? Do you have questions, guys? Kapag design sa inyong problem set, I will leave kung saan kayo magtitingin ng section lang. Okay, for example, okay, choose the most suitable W8 section para titingin lang kayo guys doon sa W8. Kung doon lang yung nililimit ko na pagtingnan nyo, doon lang kayo pipili ng design section nyo. Saan ba ang W8? Ito lang. Para ilang part lang ba ang W8? Ito. Oops. Ilang ano to? Ang W8 ay itong part lang na ito. Okay, so hanggang dito lang kayo, ganun. Okay, dito lang kayo magde-design. Dito lang kayo pipili ng section. Ganyan. Okay, WT, kalahating wide flange section, or S, American Standard. Yun. Kaya I guess, hanggang dun lang yung ating design problems. Mas okay kasi, ano, nililimit kasi tayo mag-design dito sa, sa tension member because of the connections. Okay, ang connections kasi, that is our last topic. No? Welding tsaka bolt connection. Ito meron din dito. Sa truss. Pero hindi siguro ako magbibigay ng ko-compute nyo pa yung mga member forces sa isang truss. Okay, and then you design, okay, using an angle. So, ito na yung sagot natin, class, no? We adopt the W or L 8 by 4 by 1/2 for this, etong angle na ito. Ayan. Ang angle na ito. Okay, that's the most suitable section. Okay? According to our calculations. So, hanggang doon lang, guys. Please prepare for a quiz. Okay, I will give a take-home quiz, one problem from your problem set, and then a quiz will be on Wednesday. Okay? Wednesday ng hapon, is-set ko na lang yung schedule because kayo na lang mag-solve, no? Oo nga pala, hindi pa ako nag-schedule. Okay, next week, Wednesday, from 1 p.m. to 5 p.m., you will have your quiz on tension members, no? Kasali ba, sir, yung module 1 natin? Yes, kasali yon. Okay, it will be a long quiz. Okay, then, this, module 1 and module 2. Tapos, ang schedule pala ng klase natin ay pag-usapan natin next week because hindi pa maayos yung schedule ko sa kabilang school. Okay? So, gawin nyo, to prepare for your long quiz is you solve your problem sets. Okay, that is also due next week, Friday na siguro. Kasi Friday ngayon. That's 1 week time. Okay, and please remember that I won't accept late submissions na. No? Last na yung last activity nyo. Okay, last na yun. Okay, I will only accept late submissions for those with valid reason, no, na pirmado ng ating guidance counselor. So, yeah. Okay. And guys, wag na lang. Baka makasira pa ako ng tao dito. Okay, ilan ang pumasok? I will not lecture further, no? Because next week we will have different topic that would be the design for columns and other compression members. Okay, compression members na tayo, no? I don't know, di ko maalala yung section sa ating NSCP, but you can read that. Nandoon naman yun. Okay, so I guess hanggang doon lang. Thank you for listening. And you may now leave the meeting.
Thank you, sir.
Bye, sir.
Bye, sir.
Okay, goodbye.
Bye, sir.